So we are coming from RFIDs and civil engineering into an area which may be also applied in civil engineering, but which may also be or is widely also applicable in the aerospace world, and that's again using acoustics, specifically acoustic emission, and also guided waves and whatever is related to acoustics. And Dr. Seth Kessler, I think who many of you know, who has worked for many years in that subject since his PhD, and then founded the company Metis, which now in the meantime is already existing a variety of years. They have developed to apply those techniques here with a system. He and his colleague are going to explain to us a little. It's all demonstrated here, and I think we'll see that on the camera, what is all done. A few acoustics preparation, but I think more now you are ready to say. Seth.
Hi, thank you. Again, I'm Seth Kessler. This is Greg Jarmer. We're from Metis Design. Today we're going to be demonstrating acoustic emission-based impact detection and guided wave-based damage detection using the MD7 Pro digital SHM system. So as soon as we're ready here, we're going to get started with our impacts. I'm using a small steel ball that I'm dropping on a glass plate. So first, to the right of my sensor, it takes about 2 seconds or so to rearm between each of these impacts. So I'm going to do 4 of them in total. So next below, that was maybe slightly to the left of below, and now I'm going to do to the left next. We're going to show all the results at the end. To the left, and finally I'm going to do above. That's maybe to the left of above. So next I'm going to be doing guided wave-based damage detection. Like I said, I'm going to show all the results at the end. In this case, I'm going to be using a mass to simulate damage. At this point, some of you are probably asking why I'm using a glass plate here. Up through last Friday, we had a very nice demo where we were going to use a center punch to create an acoustic signal and cause a crack in the glass, which was a really nice demo, and it showed up very nicely. However, we also found that about every 10th time we did the demo, the glass exploded into about 1 million pieces, and in consideration of those in the front row, decided that that was maybe not such a safe demo if we had to distribute safety glasses. So unfortunately, we're going to be using masses to simulate damage, but same idea here, that we're basically adding stiffness instead of reducing stiffness from the plate glass, which could be anything, composite material or a metal. So what you have up here is our data acquisition system sitting on top of a beamforming array. The beamforming array is 6 piezoelectric sensors surrounding a piezoelectric actuator. The actuator is sending a 100 kilohertz signal through the plate. It's reflecting off of these sources. It's coming back to the center, and we're using the beamforming array to look at the phase differences in order to map out the damage. So like I said, this is our data acquisition system. You can actually daisy chain these up to 24 of them with this cable. The data acquisition system weighs 20 grams and the cable weighs 10 grams per meter. We're able to collect data synchronously at 10 megahertz. We can do pitch catch or pulse echo. In this case, there's only one sensor, so we can only do pulse echo. We're downloading the data now, and in a minute we're going to switch over to show the results, but it takes roughly 30 seconds or so per node to do a scan. So we can switch over now to show the screen. Takes a couple more seconds to finish downloading that, and then bring up the GUI. Okay. So we'll load the data into the GUI. This is showing the plate. It's loading the acoustic emission. Now it's loading guided wave data. So first event was to the right side. The next event was below, slightly to the left. The next one was to the left. And the last one was above, slightly to the left. And next we had our guided wave, which was to the left. And finally we had our mass added to the bottom right. And you can see both of them in this case, which I think is pretty interesting that we're able to use a single phased array in order to catch 2 different pieces of damage using our original baseline signal. So I'll help you stay on time, and that's our presentation.